Hi folks, welcome back to Math with Captain Rod. The purpose of this video is how to use the derivative, or at least the concept of the derivative, to find the equation for the tangent line at a given point on a function. So what we're going to do is we're going to look at the function y equals 1 over x squared. We're going to try to find an equation for the tangent line. That's why I started with y equals mx plus b at the point 1, 1. So for starters, let's work on just a quick sketch of this graph just by observation here. I'm looking at that bottom and we see that we have a potential division by 0. That function is going to have a vertical asymptote at x equals 0. I'm going to go ahead and put that in there. Asymptotes are wonderful graphing aids. Once you get the asymptotes sketched, usually drawing the rest of the function is easy. So I know this thing's got a vertical asymptote there. All right. Another thing to take note of, as x gets larger and larger, the ratio 1 over x squared gets smaller and smaller. Limit of 1 over x squared as x goes to infinity is 0. So this thing has a horizontal asymptote at y equals 0. I'm going to go ahead and put that in. I like red for my asymptotes for whatever reason. Okay, now I'm only going to worry about the first quadrant because we're only interested in this graph at the point 1, 1. If I put that point in the curve, 1, 1 is maybe here. We know that this function has to approach the asymptote going this way and this way. So there's a rough sketch of what that function looks like in the first quadrant, real rough. Again, asymptotes are wonderful graphing aids. Once you have the asymptotes with just one point here, I can get a reasonable sketch, good enough to work this problem. All right, now what we're looking for is the tangent line at the point 1, 1. I'm going to go ahead and draw that tangent line. Looks something like, maybe this. Again, I've got kind of a rough sketch, so the slope's probably not going to be spot on, and I'm going to draw my tangent line in green. So what we're looking for is the equation for that line, y equals mx plus b. So I'm going to start with m, the slope. First thing we need to know is the slope of that line, and we get that from what's called the derivative. So I'm going to start by calculating the derivative of this function by definition. All right, so dy dx, derivative of y with respect to x, is equal to limit as h goes to 0 of f of x plus h minus f of x over h. So that's going to be 1 over x plus h squared minus 1 over x squared over h. That is the limit definition of the derivative. And it's coming from, again, concepts from algebra. Slope is y2 minus y1 over x2 minus x1. So this is y2 minus y1 over x2 minus x1. In my previous videos, I talked about moving over a distance h from x to x plus h. The new function value is f of x plus h. So if you're having trouble figuring out where this comes from, I would go back and look at my previous video on the derivative. That's where it's coming from. All right. So now it's a matter of calculating this value. So we got limit as h goes to 0. Let's see, the numerator of this is just screaming common denominator. Why don't we write that x squared minus x plus h squared over x squared times x plus h, the quantity squared, and all over h. I guess I'll go ahead and put that down here, which equals limit as h goes to 0. Let's see, in the numerator, x squared minus x squared, these are gone. Whoops, actually, I should probably expand that out first. I'm going to just do this off to the side. This part, this x plus h squared, expands to x squared plus 2xh plus h squared. Don't forget the 2xh part when you work these by yourselves. You have to FOIL that, x plus h, the quantity squared. So in the numerator, we have x squared minus x squared. Those are gone. Then we have a minus 2xh, and then a minus h squared. And again, that's over x squared times x plus h, the quantity squared over h, right? Now, we are looking at a fraction divided by h. So effectively, this h will cancel this one and one of these. Running out of room. So equals limit as h goes to 0 of minus 2x minus h over x squared times x plus h squared. And I think at this point I can take limit as h goes to 0. So as h goes to 0, this term goes to 0. The numerator becomes a minus 2x. And the denominator, when this h becomes a 0, this becomes x squared times another x squared. So that's x to the 4th. And one x on top, 4 on the bottom. This gives us minus 2 over x to the 3rd. So we've now calculated a function that will tell us the slope of this guy at any point, and that's what the derivative is. So that's what dy dx is. I'm going to go ahead and store that up here. Dy dx is minus 2 over x to the 3rd. I'm going to take a moment and get rid of all the stuff I don't need. So now, back to what is it we're trying to accomplish? We're trying to find an equation for this tangent line. For that, we need the slope, and that's what the derivative will tell us. So the slope of that tangent line is going to equal dy dx evaluated at x equals 1. So that's going to be negative 2 over 1 cubed, which is negative 2. And it's always handy. The reason for drawing the pictures is to make sure that our work is consistent with our expectations. I'm looking at this line here, and it's fairly easy to observe. It's got a negative slope. Even my graph would kind of indicate it's probably right around negative 2. So this negative 2 looks consistent with my picture, so I'm happy, and we'll move on. So the equation for this line must look like y equals minus 2x plus whatever b is. Next step is to find b, and we'll do that just like we would in an algebra class. We know that this thing goes through the point 1, 1, so we know that y is equal to 1. Whoops. When x is equal to 1. And it's not too tough to solve that for b. I get 3 out of that because we have to add 2 to both sides. So the equation for our tangent line is y equals minus 2x plus 3. Tangent at this point. Had I wanted to find the tangent line at any other point, most of this problem would be the same. We'd start by calculating the derivative of this function, limit as h goes to 0 of f of x plus h minus f of x over h. Evaluating it at whatever point I want to get the slope. Put that slope into this form of the line, y equals mx plus b. And then use the point, the xy, to find b. So, again, the point of this video is how to use the derivative to help find the equation of a tangent line. I hope this example helps. Have a great day.